Parliament. Let's start the paper number 21. Uh, do you have the paper with you, Sam, Finler, and Roche? Do you have? Parliament. Roche, Sam, can you hear me?
Yes, sir. I have the paper.
Yeah, okay. Okay, let's start paper number 21. This is the paper. See, our first question. In the first question, if the velocity of light c, the gravitational constant, that is universal gravitational constant is g, and the Planck's constant h are chosen as the fundamental units, find the dimensions of mass, length, and time in the new system. Now they have selected speed of light, gravitational acceleration, and Planck's constant as the fundamental units. Now we need to find the dimension of mass, length, and time in terms of c, h, and g. So how to do this? This is the first question. You know the dimension of speed of light is Lt minus 1. And the dimension of gravitational, universal gravitational constant is m minus 1 L cube T minus 2. And h is the Planck constant. Planck's constant has the same dimensions as angular momentum. Angular momentum is linear momentum into distance. So the dimension of Planck's constant is linear momentum is mlt minus 1. When you multiply this by L, that is angular momentum, Planck's constant and the angular momentum have the same units. So the units dimensions of Planck's constant is ml square t minus 1. Now we need to find the dimensions of mass, length, and time. So how to do that part? Now, if you divide g by c, let's divide g divide by c. That is m minus 1 L cube t minus 2 divided by c is Lt minus 1. So you have that is equals to m minus 1 L cube divided by L is L square, t minus 2 divided by t minus 1 is t minus 1. Now here you have g over c, that is m minus 1 L square t minus 1. Here also you have L square t minus 1. So when you can divide this term by this term, right? So L square and t minus 1 will cancel. The only remaining term will be m. So you can find m from these two. So now you can divide h divided by g over c. So that is equals to h is ml square t minus 1. G over c, now we have calculated that one. That is m minus 1 L square t minus 1. So that is L square t minus 1 will be gone. So that is equals to m divided by m minus 1 is what? M divided by m minus 1 is m square. Now you can find n. So here you have h g to the power minus 1 c, right? That is equals to m square. So you have m. M is the square root of that one. That is, we have to get the answer in the order. So how to? This is the CHG in the order of CHG. So how to take mass? C to the power half, H to the power half, G to the power minus half. This is M. This is the dimension of M in terms of CHG. C to the power half, H to the power half, G to the power minus half. So let me take the paper. So what are the answers? C to the power half, h to the power half, g to the power minus half. So answer cannot be third one or fifth one. Okay. So we have five answers: 1, 2, 3, 4, 5. In third one, the answer is c to the power minus 5 or 2. So that cannot be the answer. In the fifth one, c to the power minus half. That cannot be the answer. So now the only remaining terms are 1, 2, and 4. Then how to take? Now you know mass. Then how to find L? How to find L? Hmm. You have H is m L square t minus 1, right? And let's divide this by m. So you have h over m is equals to L square t minus 1, right? You have calculated m. Now you can divide this term by c. So that is equals to h over m divided by c. Okay, here I divided both side by m. So h of m is L square t minus 1. Now L square t minus 1 divided by c. C is LT minus 1. C is LT minus 1. T minus 1, T minus 1 will be gone. L and L is gone. Now you have H over MC. But you know, M is C to the power half, H to the power half, and G to the power minus half times C is equals to L. From this one, you can find L. So L is equals to H. First, you have to take C. C into C to the power half into C is C to the power 3 over 2. So that is c to the power minus 3 over 2. Then you need to find h. H to the power 1 divided by h to the power half is h to the power half. And when this g goes to the top, g to the power half. So L is c to the power minus 3 over 2, h to the power half, g to the power half. Then we need to find, now you know mass, length, then we can find time, right? How to find time? You know, C is equals to L T minus 1. So T equals to L over C, right? When you divide uh, here L over T, when T goes to this side, T equals to L over C. Here L is this one, C to the power minus 3 over 2, H to the power half, G to the power half divided by C. So that is equals to C to the power, when this C goes to the top, that is minus 3 over 2 plus 1, that is minus 5 over 2, H to the power half, G to the power half. So that is T. Now you know T. Here you have L, and there you have m. So the answer for the question is, what is the answer? L to the power length is c to the power minus 3 over 2, h to the power half, g to the power half, and time is c to the power minus, so answer cannot be first one, c to the power minus 5 over 2, h to the power half, g to the power half. Answer cannot be second one. Answer is the fourth one, right? Fourth one is the answer. Fourth is the answer. C to the L is c to the power minus 3 over 2, x to the power half, c to the power, g to the power half. That is satisfied. T is c to the power minus 5 over 2, h to the power half, g to the power half. So the answer is fourth one is the answer for the first question, right? Right. Answer is the fourth one. See? Here m is c to the power half. This is satisfied. This is satisfied. And this is satisfied. So the answer is fourth one is the answer. Right? Write down. Okay, then let's move to question number 2. This is the question number 2. An object is projected with a velocity 30 at an angle 45 to the horizontal. When the vertical displacement of the object is h and the horizontal displacement of the object is x, the equation of the path of the object is given by h equals to ax minus bx bar. Right? Here a and b are constant. The ratio between a and b. Now, this is the question. Second question. An object is projected with a velocity 30 meters per second, and the angle of projection is given, that is 45 degrees with the horizontal. And this is the path of the projectile. And when the vertical displacement of the object is h, the horizontal displacement is given as x. And they have also given h equals to ax minus bx square. We need to find the ratio between a and b. So how to do that? The projected velocity is 30 with the horizontal angle made is 45. When the vertical displacement is h, the horizontal displacement is x. Now you can take the components of this velocity. The vertical component is what? 30 sine 45, that is 30 over root 2. This is 30 over root 2. This component 30 cos 45, that is 30 over root 2, or you can write 15 root 2, that is easy, right? 15 root 2. This is 15 root 2. 30 over root 2 means when you multiply both sides by root 2, numerator and denominator, that is 1, right? So that is 30 root 2 divided by root 2 into root 2 is 2. So that is 15 root 2, right? So 30 over root 2 is, you can write that as 15 root 2. Now, they have given this h can be written in this format. We need to find the ratio in between a and b. So how to do that? Let's say this point is a and this point is b. This is point b and this is point a. First, you can apply s equals to ut in this direction, ut plus half a t square in this direction from a to b. When the particle travels from a to b, the horizontal displacement is x and the initial horizontal velocity is 15 root 2, and the time taken, let's say TAB, since the acceleration, horizontal acceleration is 0, this term is 0. So time taken to travel from A to B is x over 15 root 2, right? Now you can apply the same equation, S equals to ut plus half a t square vertically upward from A to B. When the object travels from here to here vertically, the vertical displacement is h. Initial vertical velocity is 15 root 2 and the time taken is TAB, right? Minus half, acceleration is 10, gravitational acceleration, and the time taken from A to B is TAB square, right? Now you have here h equals to 15 root 2 times TAB. But TAB is what? TAB is x over 15 root 2. X over 15 root 2, right? Minus half times 10 is 5 times TAB square. TAB is this one. The square of that one is x square over 15 square times 2, right? 15 square times 2. Now you have this one and this one will be cancelled out. So you have x minus 5 times 15 square is 225 into 2 x square. Now you can compare that with this equation. So how to compare this one? H is ax minus bx square, right? So by comparing these two equations, you have x square, x square. So you have a is equals to 1, a equals to 1, and b is what? B is this term. That is, you can divide this by 5. That is 4, 5. That is 1 over 90. 1 over 90. A is 1, B is 1 over 90. You need to find the ratio in between A and B, A to B. When A is 1, B is 1 over 90. So the answer is there an answer like that? So yeah, you can further simplify this one. How to simplify? So A to B ratio is 90 to 1. You can multiply by 90. So A to B ratio is 90 to 1. So the answer is, for the second question, the answer is fourth one, right? This is the answer. Yeah, 90 to 1 is the ratio. Right on. Okay, let me erase. Now question number 3. In the third question, this is the question. In the tube OP of length L and cross-sectional area A, the end O is open and end P is closed. Half of its length is filled with a liquid of density ρ if the tube is rotated about O in a horizontal circular path with an angular velocity omega. Find the pressure exerted by the liquid column on the vertical surface of NP. Now this is the question. Now let's say third. You have a tube. I'll draw it in the vertical way. And the length of the tube is capital L. And you are going to, this end is open and this end is closed. You are going to fill it half of its length with water. Right? Now, this is what you are going to do. There is a tube open at one end. The total length is L, and you are going to fill half of its length with water. So the length of the water column is L2. Now you are going to move this tube in a vertical, in a horizontal plane about a vertical axis. This is the vertical axis. You are going to rotate this tube in a horizontal circular path. So now what's going to happen to the this liquid column is this liquid column is will move to this end of the tube, right? By what is the reason? L over 2. What is the reason? Now the tube is traveling in a circular path. So for an object to travel in a circular path, there should be a resultant force towards the center, or there should be a centripetal force. Since this liquid column is also traveling in a circular path, there have to be a centripetal force. So now what happens is this liquid column will push towards this end of the tube. So the reaction force, the normal reaction force. That means that this liquid column is pushing the wall in this direction. So the wall is going to push the liquid column in this direction. So the normal reaction force on the liquid column will be in this direction. So now this normal reaction force can provide the required centripetal force for the liquid column to travel in the circular path, right? So this liquid column will move to this end in order to create the centripetal force to travel in the circular path. Now we need to find what is the question? We need to find the pressure. Find the pressure exerted by the liquid column on the vertical surface at the end P. This is end O and this is end P. So in order to find the pressure, we need to find the normal reaction. And they have given that the cross-sectional area of this tube, the cross-sectional area is given, that is A. So to find the pressure, we need to find the normal reaction. Pressure is force over area. If you know the force and the area, you can find the pressure. So now I'm going to apply F equals to ma towards the center of the circular path, towards the center. In this direction, right? This equation is applied to the liquid column. For the liquid column for the liquid column towards the center. So you have centripetal force and centripetal acceleration. Centripetal force is given by the normal reaction in between the liquid column and the wall. So normal reaction is R, so centripetal force is R. So how to find the mass of this liquid column? Mass is volume times density, right? So volume of this liquid column is A times L over 2, right? A times cross-sectional area times length is the volume. Density is mass, and we need to find centripetal acceleration. So this is the special point. So how to find the centripetal acceleration? We know that this tube is rotating with an angular velocity omega. So omega square over r, right? But here, what is the radius? When you consider the liquid column, if consider the top surface of the liquid column or the front part of the liquid column, the distance from here to here is L over 2. But when you consider distance for the rear or the back end of the liquid column, the distance from here to here is L. So when you apply omega square R, R should be the radius of the circular path, right? Sorry, omega square times R. You need to apply omega square times R into R. But in the place of R, what is the value that you need to substitute? R should be the radius of the circular path. So what is the radius of the circular path? When you consider only this liquid column, the distance from here to here is L over 2. Distance from here to here is L, right? So what is the radius? Can someone tell me what is the radius that you need to substitute? When you move from this end to this end, the radius will, or the radius will gradually increase, right? Here the radius, when you consider this surface, the radius of the circular path is L over 2. When you consider this surface, the radius of the circular path is L. From here to here, the radius will gradually increase from L by 2 to L, right? So you need to substitute average length or the average radius. Here, omega square R, here at the place of R, you need to substitute average radius. So that is A L over 2 rho omega square. Average radius is from here to here, the radius is L over 2. From here to here, the radius is L. We need to add these two things and divide by 2 to get the average radius. So that is the average radius, right? From here to here, the radius is L over 2. From here to here, the radius is L. So throughout this liquid column, the radius will gradually increase from here to here. So at the place of omega square R, you need to substitute the average radius. So average radius is the addition divided by 2. Okay. So now you can find R is equals to L rho omega square over 2. When you simplify this one, you have 3L over 2 divided by 2, that is 3L of. So the normal reaction is 3L square A rho omega square, 3L square A rho omega square over 2 into 4, 8. 2 into 4 is 8. So this is the normal reaction. But in the question, we need to find the pressure. So how to find the pressure? Acting on the surf on the tube. So this is our tube. And this is our liquid column. This is the liquid column. The force on the liquid column is in this direction, that is our normal reaction. And according to Newton's third law, there will be an equal and opposite force in this direction. So there will be a similar force in the tube in this direction. So we need to find the pressure acting on the tube, that is this R divided by the area. From this one, you can take R over A. R over A is 3L square rho omega square over A. That is the pressure acting on the tube. That is the answer. So for the question number 3, what is the answer? For the question number 3, the answer is 3L square rho omega square over 8. That is first one. First one is the answer. Right? See? For the third question, the answer is, this is the answer. 3 over 8 L square rho omega square. First one is the answer. Write down the necessary things. This is the important part in this question. At the place of R, you need to find the average radius. Average radius is from here to here, the radius is L over 2. From here to here, that is L. So throughout the liquid column, the radius will vary, right? So you need to substitute the average radius. The liquid column will push towards the wall of the tube in order to create the required, in order to obtain the required centripetal force. The centripetal force is given by the normal reaction. I'm erasing this one. Okay, next question. I guess the fifth one. Fifth question. This is the question. No, the fourth one. Fourth one. So, given below are the set of adjustments that has to be done in a spectrometer prior to use in an experiment. So, A is leveling the prism table, adjusting the eyepiece so that the cross wires of the telescope are clearly and sharply visible. Adjust the telescope to observe parallel rays of light. Adjust the collimator to give out parallel light rays. So what is the first step? First, we need to adjust the eyepiece of the telescope, right? So B is the first step. B is the first step. So answer cannot be this one. Answer cannot be this one. Answer cannot be this one. So the last step is, this is the fourth step. Okay. Level in the prism table is the last step. First, we are going to adjust the eyepiece so that the cross wires are clearly visible. That is the first step. Then we need to what is the second step? Can someone tell me? Roshan, what is the second step? Is it C or D? What is the second step? Can someone tell me? Sam, what is the second step? Huh? San, what is the second step? Oh, Vinula, what is the second step? Are you there? Can you hear me? ළමයි ඔබට ඇහෙනවද? කතා කරන්නේ නැහැ නේ මේ ළමයි. ඔයාලා මැසේජ් එකක් දාලා නේ. Hello, for the fourth one, first we need to adjust the eyepiece, right? So B is the first step. Then we are going to focus the telescope to a distance object, and we are going to adjust the telescope to observe parallel light rays, right? So C is the second step. Then only we are going to adjust the collimator to give out parallel light rays. Then by observing the parallel light rays, we are going to level the prism table. So the order is B is the first step, C is the second step, adjust the telescope to observe parallel rays of light, and D, and then after that we are going to adjust the collimator to give out parallel light rays, right? And last step is we are going to adjust, or we are going to level the prism table. මතකයි නේද පුතාලා මේක පළවෙනි කරන්නේ? පළවෙනියෙන් අපි කරන්නේ මෙන්න මෙහෙම. Telescope, there you have the telescope, and first you are going to observe a distance object and adjust the telescope. This is the eyepiece, this is the eyepiece, and this is the objective. You are going to adjust this to get parallel right. So then you are going to adjust the collimator. There you have the collimator to give out parallel right trace. Again, making collimator again parallel right trace in the එළියට දෙන්න හදනවා. ඊට පස්සේ තමයි අර මේ ටේබල් එක ලෙවල් කරන්නේ. මතකයි නේද? අර remove කරලා කරන්නේ මතක ඇතිනේ මම කතන්දරෙන් අපි කරන්නේ. හරි ඒක ලොකු සීන් නැහැ. Answer is second one is the answer. හරි next question. Fifth question. A balance with unequal arms, as shown in the figure, was used to determine the mass of an object. Okay. The object has an apparent mass of m1 when weight on one pan and apparent mass of m2 when weight on the other pan. The actual mass of the object is. How to find the actual mass of the object? Apparent weights are m1 and m2. Now you have a scale pan of unequal lengths. The length of this one is, let's say, A, and the length of this one is B. Now think the unknown mass is capital M. Capital M is the unknown mass. You need to find this unknown mass using this scale. Now let's say you are going to hang it from this side. So this mass is M. To balance this, you need a mass m1. That is the apparent mass. So when you take moment about this point, you have m times A is equals to m1 times B. Now, in the next step, you are going to interchange these masses. That means you are going to put this m to this face. The arm lengths are the same. This is B and this is A. Now we are going to put this capital M to this place, right? Capital M to this place. To balance this one, now you need a different mass, that is m2, that is the apparent mass. Okay, apparent weight. To balance this one, you need a different mass, that is m2. Okay, that is given. Now, when you take moments, you have m times b. M times b is equals to what? M times b is equals to m2 times a. Now, you need to find m. So, how to find m? M in terms of m1 and m2. Okay, you can subject from this equation, you can subject A over B. That is, A over B is what? A over B is m1 over capital M, right? From this equation, A over B is what? A over B is capital M over m2. Capital M over m2. So this is equation 1. This is equation number 2. So these two things will be the same. So 1 is equal to 2, right? A over B and A over B. From there, you have M1 over capital M is equals to capital M over M2. So when you cross multiply, you have, from there, you have M square is equal to M1 times M2. So unknown mass is square root of M1 and M2. Unknown mass is the square root of M1 and M2. So what is the answer? Answer is square root of m1 and m2. So answer is first one. First one is the answer. One is the answer. Right on. There is an unknown mass and the balance is of unequal lengths. This is A and this is B. When you hang M from this one, you need to mass M1 to balance that one. When you hang this capital M from this end, you need a mass M2. From these two, by the principle of moment, M into capital M into A is equals to M1 into B. You can subject. From that one, unknown mass is square root of M1, M2. So answer is, first one is the answer. Write down. Okay, let's move to question number, next question. Question number, what is that? Question number 6, right? This is the question. Now, focal length of a convex lens is 20 centimeter. To obtain a real image on a screen of a real object. There you have a real object. You need to obtain a real image on a screen using the lens. What is the minimum distance between the screen and the object? What is the minimum distance between the screen and the object? Can you remember? That is 4f, right? 4 times the focal length. That is 4 into 20, 80 centimeter should be the answer. In the above situation, what is the height of the image formed if the height of the object is 2 centimeter? So height of the object, the, the height of the object, 2 centimeter, we need to find the height of the image. What is height of the image? When you place the object at the minimum distance, the magnification is 1, right? So object height and the image height will be the same. So image height should be 2 centimeter. So answer is, for the sixth one, answer is second one. For the seventh one, answer is second one. Let me remind you those theories. Can you remember there is a theory for that one? I did that part in the theory class. Now, if you need to obtain, this is question number 6, right? Now let's say there is a screen. This is the screen. This is the screen. And there you have the object. I'll name it O. This is a real object. And there is a convex lens in between the screen and the object. Okay. Let's say the object distance here is u, and a real object can form a real image by convex lens. There will be an image created on this screen. This is the image 1. This is image 1. I'll name it image 1 I1. And the object distance, let's say, image distance, let's say V. And by keeping the screen and the object at the same position, that means screen is at the same point and the object is at the same point, there is another location for the lens. Let's say this is the new location. This is the new location. For this location also, we can obtain a real image on the screen. And this is the second image, inverted image. Let's say the image is I2. And here the object height is h. Here also the same object. So the object height is h. Here the image I1, the height of the image, let's say h1. And at this place, the height of the image, let's say I2. And when you place the object at a distance u, the image will be formed at a distance v, right? So by using the principle of reversibility of light, the second instance is obtained when the object distance is v. So if the object distance is v, the image will be formed at a distance u. Okay. And here the distance between the object and the screen is a constant. Let's say that is capital D. This is capital D. And the distance moved by the, what do you call, the convex lens, let's say simple D. Now, here is this theory. When you place a real object in front of a convex lens, there are two possible locations for the convex lens that you can obtain real images on the screen. If one object distance is u and the image distance is v, for the second case, the object distance should be v so that the image distance should be u. And the distance moved by the lens is simple d. Here, the distance between the object and the screen is a constant, that is capital D. Now, now you know here v plus u. Here v plus u is capital D, right? V plus u is capital D. And also v minus u is simple D, right? V minus u is simple D. V minus u is simple D. Here this distance is v, this distance is u. So the difference is the distance moved by the convex lens. From these two equations, you can find v and u. So how to find v and u? You can add these two equations. So you have minus plus v plus v is 2v equals to d plus d. So v is what? D plus d over 2, right? And again, by subtracting this, 1 minus 2 minus this one, b will be cancelled. So you have 2u equals to what? D minus d. So u is d minus d over 2. Now you can apply lens equation. This is the theory. Theory. Now you can apply lens equation for the case 1. Lens equation. So when you apply lens equation for the case situation 1, that is 1 over v minus 1 over u equals to 1 over f, right? 1 over v is the image distance. Image is on this side, so that is minus v. Minus object is on that side, so minus u. Here you have a convex lens, so focal length is negative. The focal length of the convex lens is f. Now you have, from there you have multiply by minus sign, that is 1 over v plus 1 over u equals to 1 over f. But you know v is this one, d plus d over 2, right? U is d minus d over 2, d minus d over 2. So 1 over u is d minus d over 2 equals to 1 over f. So you can simplify this one. There you can multiply by 2. Oh, you have 2 over d plus d plus 2 over d minus d is equals to 1 over f. Now take 2 out and take the common denominator. D plus d to d minus d is what? D square minus d square, right? The difference of 2 square. There you have d minus d plus d is equals to 1f minus d, and d is gone. Here d plus d is 2d, 2d times 2 is 4d. 4d equals to d square minus d square 1 half, right? Then you can find the distance moved. From this equation, you can simplify d square or simple d. Or now I'm going to find the distance moved by the convex lens. So how to find that one? You have 4df is equal to what? 4df equals to d square minus d square. From that one, you have d square equals to d square minus 4df, or the square root of that one, right? So this distance d equals to d square minus 4df. So if you know the distance between the screen and the object, that is capital D, and if you know the focal length of the lens, you can find the distance moved by the convex lens by using this formula, that is d equals to root d square minus 4df. This is one theory section. Write down if you need anything. Write down. තව ටිකක් තියෙනවා මේ මම අර minimum distance එක මේ 4f කියන එක ඊළඟට prove කරන්න. පළවෙනි මේක පොඩ්ඩක් ලියාගමු. එතකොට question if the question asks, now think, they gave you the distance between the screen and the object, that is capital E. And if they gave you the distance or the focal length of the convex lens, if the question asked what is the distance moved by the convex lens, by using this formula you can find the distance moved by the convex lens to obtain two real images on the screen, right? The distance moved by the screen is d square minus 4df. Here capital D is the distance between screen and the object. F is the focal length of the convex lens. This is just the theory part. There are some other theories. Write down that part if you need anything. I need to erase the board. This is first derivation, first one. I'm going to derive three things. This is the first one. Object height is simple h, and the height of the first image is h1 and the height of the second image is h2. Okay. And if here the object distance is u and the image distance is v, and at this place the object distance is v, so the image distance should be u. Right? Okay. Now I'm going to do the second derivation from this one. Also, you can get that part. But now I'm going to again apply the lens equation. You can either apply lens equation to the first case or the second case. This is the second derivation. So now you know the distance moved by the what do you call the convex lens is what? D square minus 4df, the square root of that one. Okay, if you know d and f, you can find this one. Now the second case is I'm going to apply lens equation 1 over v minus 1 over u equals to 1 over f. Okay, now so for the first case, for the first situation, I'm going to apply lens equation. When you apply the sign convention, minus 1 over object image is at this side, so minus 1 over v minus 1 over u equals to 1 over f. So 1 over v, 1 over u equals to 1 over f when you multiply by the negative sign. So 1 over, for the place of, let's say v plus 1 over u, for the place of u, from this equation, you can substitute capital D minus v, right? U is from this equation, D minus v. Do you understand? U is D minus V. So that is equals to 1 over F. Now I'm going to simplify this one. You can take common denominator, that is dV minus V square. There you have D minus V plus V when you take the common denominator. Clear? That is equals to 1 over F. Minus V and V are gone. So you have to now cross multiply. That is VF equals to dV minus V square. From this one, you can take these terms to this side, right? So you have V square minus D times V plus DF is equals to 0. That is V square minus dV plus dF equals to 0. This is a quadratic equation that is of the form ax square plus bx plus c equals to 0, right? So how to find V? Here at the place of x, you have v. So you can find v. How to find the roots? Roots minus b plus so minus root b square minus 4ac divided by 2a, right? Can you remember? So v is minus b. Minus times minus d is d. Plus so minus square root of b square minus 4ac. Square of this one is d square minus 4 times 1 into df. So 4df divided by 2 times 1 is 2. So you have v equals to d plus so minus the square root of d square minus 4df over 2. Right? But, yeah, this is v. V is the image distance. So, now this v or the image distance should be a real value. Okay, this cannot be imaginary. So this term should be the image distance or v should be real. For that to happen, the thing inside the root should be positive, right? If this is negative, this term is negative, it will be imaginary. For v to be real, v is the image distance. To be real value, the term inside the root, that is d square minus 4df, should be greater than or equals to 0. From that one, d square should be greater than to 4df. D cannot be 0, so you can cancel 1d. So d should be greater than to 4f. So you can say the minimum distance is 4f. So to obtain a real image, image on a screen, the distance between the screen and the object should be greater than 4f. That means the minimum distance should be 4f. Let's say the focal length of the convex lens is 20 centimeter. So the focal length of the convex lens, if the focal length is 20, the minimum distance should be 80, right? So if you place an object at a distance 40 or beyond, you can obtain a real image. But if let's say you keep the object at a distance 70 centimeter, so you cannot obtain a real image. So the minimum condition is the minimum distance between screen and the object should be 4f. If you place the object beyond 4f, there are two possible ways that you can obtain a real image. That is, if one is u, this one is v, the second case is this is v and this is u, right? If the distance is lesser than 4f, you cannot obtain a real image on the screen. So the minimum distance is, what is the minimum distance? The minimum distance is 4f. That is the second case. So this is the second derivation. Then I'm going to derive another one. Write down. Now this is first one, the distance moved by the lens. There you have the minimum distance between the screen and the lens. Sorry, screen and the object. Capital D is the distance between screen and the object. Here, there is another thing. I didn't mention that one. There are two, for v, there are two things, right? That is d plus something and d minus something. But here, v cannot be greater than d, right? This image distance cannot be greater than d. So you have to take only the minus sign, okay? Here, if this is d plus something, එම කියන්න බෑනේ. මෙතන දැන් දෙකක් වෙනවනේ. මොකද්ද අපි ගන්න ඕනේ? ප්ලස් එකද මයිනස් එකද? මෙතන divide by 2 එකක් තියෙනවානේ. 2 times එක. එතකොට v කියන එක d ට වඩා අඩු වෙන්න පුළුවන් නේද? minus. ඕකේ දෙකක් එන්නේ. මෙතන මෙහෙමයි හරියද? මේකේ දෙකක් එන්නේ පුතාලා situations මෙහෙමයි. If v is positive, that means if v is d plus root d square minus 4df over 2, then u is d minus, then එයාගේ අනිත් එක d minus d square minus 4df over 2. තේරුණා කියන එක? If v is d plus this one, u is d minus this one. If v is d minus this one, then u is d plus this one. ඒකයි මේ දෙකක් වෙන්නේ. හරිද? ඒ කියන්නේ මෙහෙම situations දෙකක් තියෙනවානේ. ඒකයි එහෙම එන්නේ. හරිනේ? හරි. කොහොම හරි the v should be real. For this to be real, this term should be greater than or positive. That means the minimum distance between the object and the screen should be 4f. Now I'm going to do this third derivation. Third derivation. Third derivation. That is, from this one, the magnification is, from case 1, the linear magnification is image distance over object distance is equals to image height or object height, right? If image height is h1 and the object height is h, that is equals to v over u. V is the image distance or object distance. And from the second situation, you can write the linear magnification. Here the image distance is u. Object distance is v. Image distance over object distance is equals to image height is h2, object height is h. This is first one and this is second one. You can multiply 1 by 2. 1 into 2. That is v over u into u over v. That is h1 over h times h2 over h. This is 1, right? This is 1. So you have h square equals to h1 h2. So h is root h1 h2. So if you know the heights of the image at the two situations, from this equation you can find the height of the object. Clear? Height of the object can be found. If height at first instance is h1, second instance is h2, h1, h2, the square root of that one is the height of the object. Write down. This is the third one. Now you know three things. The distance moved by the lens is d square minus 4df the square root. To obtain a real image, the condition is the minimum distance is 4f. That means the distance should be greater than 4f to obtain two real images. And if you know the heights of the real images, you can find the height of the object using this formula. Now I am going to give you a summary of this section. The summary is this one, very important. Summary. To obtain a real image of a real object on a screen, using a convex lens. First thing is the minimum distance should be 4f. Let's say this is the screen and this is the object. Now, when you keep the object at the minimum distance, that is 4f, to obtain the real image, the image distance and the object distance should be the same. If this is 2f, this should be 2f. So, if you keep the object at the minimum distance, that is 4f, when you keep the real object, there will be a real image, okay? But the object distance and the image distance should be the same. So what can you say about the magnification? Magnification is image distance over object distance, that is 2f over 2f, that is 1. So if the height of the object is h dash should be equals to h, right? So if the distance between the object and the screen is lesser than 4f, what happened? You cannot obtain a real image. If the distance between the screen and the object is lesser than 4f, you cannot obtain the image on a screen. But if the object distance is greater than 4f, I'm going to erase these things. Now let's say image distance is greater than 4f. Third one, the object distance is greater than 4f. What happens is, this is the object, okay? This is object, and now the distance is greater than 4f. Now at this condition, there are two possible locations. If this is u and this is v, there you have the image I1, and there is another location. As I drew in the first case, if this is v, this is u, and the distance moved is d, that is equals to, can you remember? D square minus 4df, the square root, right? Now, if you place the object at the minimum distance, the lens should be kept at the center to obtain the real image. If it is lesser than 4f, you cannot obtain the image. If the distance is greater than 4f, there are two possible locations. If is u, image distance is v, then in the second case, the image distance is u and the object distance is v, and the distance moved by the screen or the lens can be found as shown below, right? තේරුණාද පුතාලා? මේවා තේරෙනවද මේ සෑන් රොෂෙන් පිනුල සහන් Sam, do you understand? Yes. Okay, this is the summary. Write down the summary. Write down. So if you keep the object at the minimum point, there are only one location. There are no two locations. But if that is greater than 4f, there are two possible locations. But if the distance is lesser than 4f, you cannot obtain a real image. All right. Let's move to the question. Now you can do. Now in the sixth question, you have the focal length of a convex lens is 20. To obtain a real image on a screen of a real object using this length, what is the minimum distance between screen and the object? That is 4f, right? Minimum distance is 4f. So 80. So at this point, at this condition, that means the distance between the object and the screen is 4f. There are only one location, right? For the lens. The lens should be kept at the center. Now you can find in the above situation what is the height of the image formed if the height of the object is 2 centimeter. So at this point the magnification is 1, so the object height and the image height should be the same. So the height of the image should also be 2 centimeters. So for the 7th one, answer is second one. For the 6th one, answer is also second one. So clear? That is the answer. So I can again show that the object distance and the image distance are the same. How to show that one? Let me erase these things. Let's move to the question. Now, from these conditions, you know that the minimum distance between the object and the screen is 4, that is 80 centimeter. If you need to prove, let's say in an essay question, you have been asked to show that the magnification is 1. So how to show that the magnification is 1? You can do that. This is seventh one. Without just taking that magnification is 1, you can prove that one. How to prove that one? Let's say this is object height is h and this is the screen. But now you know the distance between screen and the object, that is 4f or 80 centimeters. The distance is from here to here. The distance is 80 centimeter. Now let's say you don't know the so actually, to obtain the real image, the lens should be kept at the center, right? Let's say you don't know the location of the lens. We are going to find it. Let's say you place the lens at this point and this distance is u. So the image distance is v. They have given the focal length. Focal length is minus 20. Since this is a convex, focal length is negative. There you have the image. Image height is h dash. Now you can apply lens equation. How to apply lens equation? 1 over v minus 1 over u equals to 1 over f. Apply the sign convention minus, because the image is at this place, minus 1 over v minus 1 over u equals to minus 1 over f. So 1 over v minus 1 plus 1 over u equals to 1 over f when you multiply by the negative sign. Now there you have 1 over v plus 1 over u. So how to find u? This is 80, this is v. So u is 80 minus v, right? 80 minus v is u is equals to 1 over focal length is 20. Now you can take the common denominator. So 80 minus v plus v divided by 80v minus v square is equals to 1 over 20 minus v. This one is gone. So that is 80 into 20. That is 1600 is equal to 80v minus v square. So v square minus 80v plus 1600 is equals to 0. So this is v minus 40 all things square equals to 0. So can you see the answer for v is only one rule. V is 40 centimeter. So when v is 40, u is also 40. So the magnification is v over u, that is 1. Since magnification is 1, h dash of h is 1. So h dash equals to h, right? So when you place, this is very important. When you place the object at the minimum distance, the lens should be placed at the center to obtain the image on the screen. There are no two possible locations. But if this distance is greater than 4f, there are always two possible locations. But if this distance is lesser than 4f, you cannot obtain a real image. Clear? You can show that the magnification is 1. Write down that part as if you need. Write down, Putha. These things are important. Okay. Next question. Question number 7, I guess. No, 8. We did 7. Question number 8. Consider the following statement made about the capacitors at the steady state. You have a capacitor combination. This is question number 8. 1, 2, 3, and 1, 2, 3. These capacitors are connected in parallel and it is connected to a cell of 10 volt. This is 10 volt. Capacitance is, every capacitance is given in microfarad. This is 6, 3, 2. This is 3 and this is 2. The second row you have 6, 4, 2. 6, 4, 2. Okay. A statement, the charge stored on 3 microfarad. A statement, I'll write a statement. Charge stored in 3 microfarad capacitor is 10 microcoulomb. That is the first statement. B statement, the charge stored on both 6 microfarad capacitors is the same. The charge stored on 6 microfarad is same. That is the second statement. Third statement, potential difference across the 2 microfarad capacitor is 5 volt. And the potential difference across the second 2 microfarad, this one in the second statement, the potential difference across 1 2 microfarad capacitor is 5 volt. And the potential difference across the second 2 microfarad capacitor is 5.45 volt. That is the question. These are the statements. Okay. Now we need to find the charge stored on the 3 microfarad capacitors. Now, as you can see, these 3 are connected in series and these 3 are connected in series. And this set is parallel to this set. So the potential difference is 10 volt. The potential difference across these three capacitors is also 10 and the potential difference across these three capacitors is also 10, right? Same potential difference. So if the charge stored on this capacitor is Q1, the charge stored in this one is also Q1, this one is also Q1, right? Why? These three are connected in series. If the charge stored in this capacitor is Q2, here also Q2, here also Q2, right? So let's say the charge stored on this one is Q1. So this one also Q1, here also Q1. If the charge stored on this capacitor is Q2, here also Q2, here also Q2, right? So how to find the charge stored on this 3 microfarad capacitor? You can find the equivalent capacitance. So how to find the equivalent capacitance? I'll erase these 3. Now A state. I'll again draw these 3 capacitors. There you have 6, there you have 3, there you have 2. And the potential difference is 10 volt. And the charge stored on each capacitor is Q1. So what is the equivalent capacitance of this one? Here you have 6. Here you have when two 6 microfarad capacitors are connected in series, that is 3, right? මතකයිද ළමයි? 6 දෙකක් සීරීස් ගැහුවොත් equivalent is 3. මේක නිකන් ඔයාලට හිතන්න පුළුවන්, මේක ඔයාලට හිතන්න පුළුවන් 6 microfarad ඒවා දෙකක් සීරීස් ගැහුවයි මේක that is similar to 3 6 microfarad capacitors connected in series. 6 තුනක් series ගැහුවොත් එන්නේ මොකද්ද? 6 divided by 3, that is 2. So altogether there you have 6 microfarad, there you have 2 6 microfarad in series, there you have 3 6 microfarad in series. So altogether 1 2 3 3 plus 3 6. So the equivalent is actually, how to find the equivalent capacitance? There are 6 microfarad capacitors connected in series. So equivalent is 6 microfarad divided by 6, that is 1 microfarad. So the equivalent of these free capacitance is 1 microfarad, or else you can find it in this way. How to find this? This method is easy. How to find this one? These three are connected in series, so that is similar to resistors in parallel. So 1 over C equivalent is 1 over 6 plus 1 over 3 plus 1 over 2. So that is, you can take 6 common, 1 plus 2 plus 3. That is 6. C equivalent is 6 over 6. That is also 1 microfarad. You can do either way. Okay, this is easy. When two 6 microfarad connected in series, that is 3. When three 6 microfarad connected in series, that is 2. So altogether you have 6 microfarad capacitors connected in series. So that is 6 over 6, that is 1 microfarad. Now you can find the charge stored in the equivalent system. So what is the charge stored? That is Q1. Charge stored is CV, right? C is 1 microfarad. Potential difference is 10. So the charge stored is 10 microcoulomb. So the equivalent combination stored 10 microcoulomb charge. So the charge on this one is also 10. Charge on this one is also 10. The charge on this one is also 10. So in the statement A, the charge stored in 3 microfarad capacitor is 10 microcoulomb. That statement is completely correct. That is correct. Right? That is correct. Now, in the second question, or the second statement, B statement, they are saying that the charge stored on this 6 microfarad capacitor and this 6 microfarad capacitor is the same. For that to happen, the equivalent capacitance of these three should be equal to the equivalent capacitance of these three, right? If the equivalent capacitance of this one and this one are the equal, the voltage is the same. If equivalent capacitance is the same, then the charge stored on this row and this row will be the same. But here you have 6, here you have 6, here you have 2, here you have 2, but there you have 3, there you have 4. So the equivalent capacitance of this branch and this branch are different. Since equivalent capacitance are different, according to CV equation, the charge stored on these two columns should be different. So the charge stored on this one and this one are not equal. So in the B statement, they are saying that the charge stored on this one and this one is the same. That is wrong. Clear? That is wrong. Because the equivalent capacitance of this branch and the equivalent capacitance of this branch are different. Since the equivalent capacitance are different, the charge stored cannot be the same. But the charge stored on here, here and here are the same because they are connected in series. The charge stored on this one and this one are the same because they are connected in series. But the charge stored on this one and this one are not same. Why? The equivalent capacitance of this branch and the equivalent capacitance of this branch are not the same. So B statement is wrong. Right? Now in the C statement, they are saying the charge stored on this one is 5 and charge stored, sorry, the potential difference across this one is 5 and the potential difference across this one is 5.45. So how to find that one? I'll do it for a general case. Let's say you have three capacitors connected in parallel, sorry, series. This is for the C state. Say you have three capacitors. This is C1, C2 and C3 connected in series and the potential difference is V. Charge stored is the same because they are connected in series, but the potential difference is different. Why? Charge same, capacitance is different. So the potential difference is different and the potential difference is V3. So you can apply for the first capacitor Q equals to C1 V1, second Q equals to C2 V2, third Q equals to C3 V3, right? Now you can take a ratio in between V1 to V2 to V3. So how to take the ratio? V1 is Q over C1, Q over C1, V2 is Q over C2, V3 is Q over C3. So V1 to V2 to V3 ratio is 1 over C1 to 1 over C2 to 1 over C3. So how to find V1? The ratio is 1 over C1 to 1 over C2 to 1 over C3. So how to find V1? The total potential difference is V. The total has to be multiplied by 1 over C1 and has to be divided by the addition, that is 1 over C1 plus 1 over C2 plus 1 over C3. When you take the common denominator, you have, just take, there you have C1 and C1 will be gone. So C2 C3 times V divide by C1 C2, C2 C3, then C2 C1. Sorry, C1 C3, C1 C3. This is the answer. If it is V1, there you have C2 C3 times V divide by, you have to take each two pairs, C1 C2, C2 C3, C1 C3. Then by using the pattern, you can write V2. How to find V2? V2 is, if that is V1, you have C2 and C3. If this is V2, you have C1 and C3. C1 C3 times V divide by C1 C2, C2 C3, C1 C3, right? So V3 is what? V3 is, without C3, you have to put C2 C1 or C1 C2 times V, C1 C2, C2 C3 plus C1 C3. That is how the potential difference across each capacitor is found. Everyone else, if this is V1, very easy. How to find V1? The total potential difference is V times C2 C3, C2 C3 divided by C1 C2, C1 C3, C2 C3. If this is V2, how to find V2? V2 is V times C1 C3 divided by C1 C2, C1 C3, C2 C3, right? In a similar pattern, you can find the potential difference, right? If three capacitors are connected, the potential difference is found by this pattern, right? Then you can easily find the potential difference across the 2 microfarad capacitor at the two instances, right? This is a general case, proof for a general case. Lamai, if there are only two capacitors, that is very easy. Let's say, listen carefully. You have two capacitors. This is C1 and this is C2. The total voltage is V. If this is V1 and this is V2, how to find V1? Very easy. V1 is V into opposite capacitance, that is C2 times V divided by C1 plus C2. Very easy. So how to find V2? V2 is, you have to multiply by opposite capacitance. V times C1 divided by C1 plus C2. එහෙම තියෙනවා නම් හොයන්න. දෙකක් තියෙනවා නම් හොයන්න. If there are three, you have to use this pattern. Clear? V1 is equals to V times C2 divided by the addition. V2 is V times C1 divided by the addition. If there are two. If there are three, just use this pattern. Write down. Clear? Now you can find the potential difference across this one and across this one. How to find that one? I'm going to erase this part. So this is for the statement C. Let's say the potential difference across these two is V dash. So how to find that one? You have to take the multiplication of these two. That is 6 into 3 into voltage is 10. Divide by the addition of each two. 6 into 3 is 18 plus 6 into 2 is 12 plus 3 into 2 is 6. That is the potential. So that is 180 divided by, here there you have 18, 18, 36. 36. So that is 10 divided by 2, that is 5 volt. 5 volt. And the potential difference across this one is V dash. The potential difference across this one, let's say V double dash. So how to find V double dash? You have to take the multiplication. 6 into 4 is 24 times total voltage 10 divided by 6 into 4 24 plus 6 into 2 12 plus 4 into 2 8. There you have 240 divided by, there are 20 24. How much? 44. So 240 or 44 is how much? 240 or 44. 240 or 44. That is 5.45. 5.45 volt. So the potential difference across this one is 5 volt and this one is 5.45 volt. So C statement is correct. So in the statement A, the charge stored on 3 microfarad is 10 microcoulomb. That is correct. The charge stored on these two are same. That is wrong. In third statement, the potential difference across this one is 5 and this one is 5.45. That is correct. So answer A and C are correct. A and C are correct. So what is the answer? For the A and C are correct. So for the eighth one, answer is this one, right? This one is the answer. Answer is 4 is the answer. Right? That is the answer. Right down. If you need to find the potential difference across this one, how to find that one? First, you need to take 6 into 2 into 10 divide by 6 into 3, 6 into 2 plus 3 into 2. If you need to find the potential difference across this one, you need to find 3 into 2 times 10 divide by the addition of the each product. Addition of each product, right? C1, C2 plus C2, C3, C1, C3. Clear? Okay. Next question. Question number 9. Read the question. A circular table rotates around its axis at a speed of 5 revolutions per second. The table is rotating and the angular velocity is, or the frequency is 5 rps, 5 revolutions per second. A source of frequency 1000 hertz. The frequency of the sound source, frequency of the source is 1000 hertz. 1000 hertz is rigidly attached to the table at a distance of radius is 0.7 meters from the axis. What is the maximum and the minimum value of the frequencies as heard by a stationary observer standing at a certain distance away from the table? The velocity of sound in air, is 352 meters per second. We need to find the minimum, the maximum and the minimum frequencies heard by an stationary observer. So how to find this one? Now, there is a table. A table is rotating with a frequency 5 rps. You can find the angular velocity, that is 2 pi f, right? Now, there is a stationary observer. I'm going to draw the plan view or the top view. Now I'm going to look the table from top and the image is going to, I'm going to draw that image. This is the table and it is rotating with an angular velocity omega. So how to find omega? Omega is 2 pi f. So that is frequency is 5. So the angular velocity is 10 pi rad per second. This is rotating with an angular velocity 10. Now there is a stationary observer. He is at rest. Now, the frequency, there is a sound source connected at a distance of 0.7. The frequency heard by the observer is maximum. Frequency is maximum when the source is coming towards him. So let's say at this point, the source is coming towards him. This is the source. The source is at a distance. This is r, that is 0.7 meters. The velocity of when the source is coming towards the observer, the frequency heard is maximum, right? Now the emitted frequency is f, that is 1000. The emitted frequency is, let's say, f naught, that is 1000 hertz, that is given. And let's say the velocity of the source is v, and the velocity of sound, we can find the velocity of source. How to find the velocity of source? This is perpendicular or the tangential velocity. How to find the Putala? How to find this tangential velocity? This is rotating with an angular velocity omega. Radius is known, so you can find the tangential velocity. Tangential velocity is r omega. R is how much? 0.7. Omega is 10 pi. So that is 7 pi meters per second is the velocity of the source. This is 7 pi, right? And sound is traveling with a velocity of 352 hertz. That is also given. 352 meters per second. Sorry, 352 meters per second is the velocity of sound in air. And the observer is at rest. So how to find the frequency? The maximum frequency is velocity of sound with respect to the observer divided by velocity of sound with respect to the source times the actual frequency. Sound with respect to the observer is 352, right? Observer is at rest, sound is traveling. So the velocity with respect to observer is 352. Sound with respect to the source, sound is traveling 352 in this direction. Source is traveling in the same direction with 7 pi. So the relative velocity is 352 minus 7 pi times the actual frequency is 1000. So when you simplify this one, you can simplify. Here pi is 22 over 7, right? Pi is 22 over 7. You can cancel this 7. So you have 352,000 divide by 352 minus 22, that is 330. 330. So the maximum frequency should be greater than 1000. What is the answer? That is 352 divided by 330. That is 1066. Here, 1066 hertz. 1066 hertz. Right? That is the maximum frequency. So minimum frequency, the frequency is minimum. This is the observe at rest. The frequency is minimum when the, what do you call, the object is moving away from the observer. When he is traveling away, that means somewhere at a location like this. When this is the source, it is traveling away from the observer. This is the tangential velocity. At this instance, the sound is traveling in this direction. Velocity of sound is 352 meters per second. Source is traveling in this direction, that is 75 meters per second in this direction. The produced frequency is f naught. So how to find the minimum frequency? This is the radius. The minimum frequency is velocity of sound with respect to the observer divided by velocity of sound with respect to the source times the actual frequency. Velocity of sound with respect to the observer is at rest, sound is traveling this direction, so the velocity is 352. Sound with respect to the source, sound is traveling 752 with a velocity, with a velocity of 352 in this direction. Source is traveling with a velocity 7 pi in this direction, so the relative velocity is addition. 352 plus 7 pi. 7 pi is 7 into 22 over 7 times the actual frequency is 1000. 1000. So that is 352,000 divided by 374. When you divide this one, 374. What is the answer? There you have 352,000 divided by 374. So the answer is 941. 941 hertz. 941 hertz. So the maximum frequency is 1066, which is greater than 1000. The minimum frequency is 941 hertz. So when the source is rotating in this circular path, always the frequency heard by the person is lesser than 1066 hertz and always greater than or equal to 941 hertz. Okay, the maximum frequency is heard when the source is coming towards him. The minimum frequency is heard when the source is moving away from him. Clear? So these are the this is the answer. So the answer for that question, what is the answer? Minimum, no, maximum 1066 and 941. Answer is fourth one. Fourth one is the answer. Okay, write up. Adi Putala. 90s done. Samay, when we are doing these questions, if you have any doubts on some particular sections, let's say you have a doubt on capacitors, note down somewhere and go to your theory book and get it clarified. Okay. Okay. Next one, 10th one. Shit. In the 10th question, a parallel plate capacitor is connected to a cell. When the EMF of the cell is increased to a factor of 4, that means the EMF is EMF has become 4 times the electric field between the plates. They're asking what happens to the electric field. Okay. Now, for a parallel plate capacitor, 10th one, the charge stored in the capacitor is Q equals to CV, right? Let's say this is the capacitor and this plate is positive and this plate is negative. There will be an electric field from positive to negative. How to find this electric field strength? That is from from the Gauss. We did that in the Gauss section. Sigma over epsilon naught. Sigma is surface charge density, so that is Q over A epsilon naught. This is the E is the electric field strength. Now they are going to, let's say, the potential difference across the capacitor is 4 times. That means the potential, initially the potential difference was V. Now V becomes 4V. When V becomes 4V, the C is same. So what happens to the charge? The charge also becomes 4Q, right? When this one becomes 4 times, this is constant, the charge becomes 4 times. When charge becomes 4 times, from this equation A constant, this one constant, the electric field strength will also become 4E, right? So the electric field strength becomes 4 times. So what is the answer for the question? For the 10th one, the answer is becomes 4 times. Answer is fourth one is the answer. For the 10th one, answer is 4. For the 10th one, answer is 4. Right? Electric field strength is sigma over epsilon naught. Sigma is the surface charge density. Surface charge density is the charge on the surface divided by the surface area. Q over A is the sigma. Surface charge density is Q over A. Next one. Fourth, 11th one. A vessel containing a liquid of density rho is projected vertically downward with an initial velocity u. When time t equals to 0 falls under gravity, atmospheric pressure is h. Okay. If the air resistance is negligible, then the pressure at a point h vertical distance below the liquid surface when time t equals to capital T is. How to find this? This is very when an object is free falling, the pressure at each and every location should be the atmospheric pressure. So the pressure at a depth h should also be the atmospheric pressure h naught, right? I'll remind you the theories. For the 11th one, 11th one, this is the theory. Let's say you have a beaker and the beaker is at rest or traveling with constant velocity. Rest or traveling with constant velocity. The pressure at a depth h, the pressure is P. At this point, you have P atmospheric pressure. So pressure at a depth h is PATM plus, this is case 1, PATM plus H, rho G, atmospheric pressure, height, density of liquid G. Now let's say you have this beaker in an accelerating lift. The lift is accelerating upward with an acceleration A. This is the beaker and this is the point at a depth H. Okay. There you have the same atmospheric pressure. The pressure at this point is P. So how to find P? This P is PATM plus H rho. Since this is accelerating upward, that is PATM plus H rho G plus A. Okay. Now let's say third one, the lift is accelerating downward. There you have the lift. The lift is accelerating downward. The pressure at a depth, simple H, is P. There you have the atmospheric pressure PATM. You can find P, that is PATM plus H rho G minus A. So what happens when this acceleration becomes G? That means, let's say the lift is free falling. The lift is free falling. So what happens to the pressure? This is the lift. Free falling means the acceleration is G, right? There you have the point at a depth h. The pressure is P. There you have the atmospheric pressure. You can find P equals to PATM plus H rho G minus G, right? These terms become zero. So the pressure is PAT. So when the object is free falling, the pressure at each and every location will be the same, that is atmospheric pressure. So for the question, when the object's atmospheric pressure is H naught, now the object is free falling and they are asking the pressure at a depth H. So the pressure is the atmospheric pressure H naught. So the answer is H naught. So for the question, the object, the container is free falling under, that means the object is falling vertically under gravity. We need to find the pressure at a vertical distance h. So that is equals to the atmospheric pressure h naught. So the pressure at a depth h is h naught. Answer is second. For the 11th one, answer is second one. Write down the theory section if you need anything. Okay. Next on 12th one. This is the question. When a uniform steel wire of length L is suspended from a fixed support as shown in the figure A, this is figure A. This is figure A. Can you see? And different loads are attached to its lower end. Now, at the base of W, you are going to attach different W. The extension E of the wire changes with the attached weight W as shown in figure B. This is figure B. When W varies, the extension will vary according to this graph. Now, another steel wire of length L, that means it has the same length as this one, is attached to the lower end of the first wire. The cross-sectional area of the wire is twice. Area is 2 times of this one. Which of the following graphs correctly represent the variation of the extension of the composite wire with the weight W when the loads are now hung from the lower end of the composite wire? Now we need to find the new graph. Okay. Then පුතා මෙහෙමනේ 12. Now in the question, you have a wire. A load is attached to this one. The load is W. The length of the wire is L and the cross-sectional area of the wire is A. Can you remember from your knowledge on elasticity, Young's modulus equals to stress over strain? From that one, you can derive F equals to AY over L times X, right? X is the extension, A is the area, Y is the Young's modulus, L is the length, F is the applied force, X is the extension, right? Now, for this combination, the force is W, area is A, Y over L, and the extension produced is E. Now, when you plot the graph in between this and this one and this one, you have y equals to mx, right? Y, if this is y-axis, this is x-axis, that is of the form y equals to mx. They have given the graph, that is, if this is the weight, no. The graph was in between what? Can you see? The graph is in between E and W. So you have to subject E. When you subject E, you have, I'm going to subject E. E is the extension. E is what? L over AY times W. L is the initial length, constant. Area is a constant. Young's modulus is a constant. When you vary W, extension will vary. That is of the form y equals to mx. So if this is the extension, this is the added load, the graph is of the form y equals to mx. Clear? And also, see now, they have given when this is E naught. See, when the extension is E naught, or when the load is W naught, the extension is E naught. Can you see? In the figure B, when the load is W naught, the extension of the wire is E naught, that is given. So the same graph is here. When the load is W naught, extension is E naught. Now, what they are going to do is they are going to attach another rod of the same length, but having a cross-section area 2 times of this one. Clear? Now, Butala, draw it again. This is our first row. And now they are going to attach another rod. And then only you have the weight, W. The length of this one is L. Area of this one is A, and area of this one is 2A. And in the question, they have given it is made of same material, right? Steel, yeah, both made of steel. Since both made of steel, they have the same Young's modulus. So, Putala, the total extension, how to write the, I'll name this section 1 and this is section 2. The total extension is due to this attached weight, this one will extend and this one will extend. So the total extension is the extension of the section 1 plus the extension of the section 2, right? Clear? Extension of section 1 plus extension of section 2. The total extension is E. So extension of section 1, how to, from this equation, Putala? You know, F equals to, or W equals to AY over L times extension, right? AY over L times extension. So AY over L times extension. So how to find, Putala, the extension of section 1? That is WL over AY. So weight acting on this one is W, L is L, area is A, Young's modulus is 5. Extension of the second one, the same weight is acting on this one as well, length is same, but the area of that one is 2A. 2A times 5. Clear? Now you can simplify. E is equals to, you can take WL over AY out. From that one, you have 3 over 2. Now you are going to draw the graph. So E is what? You can subject E. E is 3L over 2AY. 3L over 2AY times W. Clear? 3L over 2AY times W. This is the constant. So this is also of the form y equals to mx. If this is y x-axis and this is y-axis, that is also of the form y equals to mx. But Putala, here, see, the gradient is, here, the gradient is m1. m1 is L over ay, right? In this graph, the gradient is, see, gradient is m2, that is 3L over ay. Sorry, 3L over 2ay. That means, Putala, the gradient at this case is 3 over 2 times the gradient at this case, right? See, m2 is the gradient of this graph. That is 3 over 2 times gradient of this graph. So the gradient of this graph should be greater than this one. Clear? Should be greater than this one. Here y equals to m1x, here y equals to m2x. So the gradient of this graph should be greater. Clear? Then let's move to the answers. See, Butala, the gradient, we need to find the new gradient. That is also of the form y equals to mx. So this cannot be the answer. See, this cannot be the answer. Why? Here also the gradient is E naught over W naught. This cannot be the answer. This cannot be the answer. Why? Here the gradient is lesser. This can be the answer and this can be the answer, but this cannot be the answer because the gradient at this place is E naught over W naught. Here that is lesser than E naught over W naught. So answer should be 3 or 4. So how to come up with this correct answer? How to come up with this correct answer? Yeah, we can do that. Now, Butala, here, see, the gradient of this graph is m2. That is 3 over 2 m1. m1 is the gradient of this graph. What is the gradient of this graph? Opposite over adjacent, tan theta. So the gradient is E naught over W naught. 3 over 2 E naught over W naught. You can also write this one, m2 equals to E naught over 2 over 3 W naught, right? 2 over 3 W naught. Clear? That means 2 over 3 W naught. That means, Putala, this is M2 equals to E naught divided by 0.66 W naught. Clear? Now I'm going to draw this graph. That is y equals to mx. This is the extension and this is the law. That is y equals to mx. See, the gradient is E naught to 0.66 W naught. That means if this is E naught, the value at this point should be 0.66 W naught. Can you understand? Then what is the answer? Let's move to the graph. Now you have fourth one and third one. See, Puta, here when this is E naught, this can be 0.66 E naught. But here, Puta, when this is E naught, this value at W is lesser than half W, right? So half W is somewhere there. This value is even lesser than 0.5 W. So this cannot be the answer. This can be the answer. Why? When this is E naught, the value at this point can be 0.66 W naught, right? But this cannot be the answer. At the beginning, we remove this one, and this one. The remaining answers are 3 and 4. The fourth also cannot be the answer. Why? When that is E naught. See, Putala? When this is E naught, this should be 0.66 W naught. So the answer is third one. Third one is the answer. Very important. Write down, Putala. Mute kind. If you draw that graph on this graph, the gradient is greater. When this is E naught, this value is 0.66 W naught. Right? Write down, Putala. Okay, next question. Thirteenth one. In the given circuit, all the diodes are identical, and the barrier voltage is 0.7 volts. So those diodes are silicon diodes. Consider following statements regarding the resistors R1 and R2. Now, what is this symbol? This symbol is the supply. We are supplying an AC voltage, right? Not a DC. So the voltage or the current will be fluctuating in both the ways. There will be a positive current as well as a negative current. Consider following statement regarding the resistors R1 and R2. Let me draw this one, 13th one. Statements the direction of the current flowing to R2 changes from moment to moment. Current to R1 is always flows to R2. At some point, current to R1 is greater than the current to R2. We'll see. This is question number 13. Hariputala. This is the circuit diagram. Now, an AC voltage is supplied. Let's first consider the positive cycle. Let's say initially in the positive cycle, let's assume in the positive cycle, this voltage at this point is positive and the voltages, the potential at this point is positive and the potential at this point is negative during the positive cycle. And I'll again draw this circuit. This is the AC supply, diode. There you have another diode and a resistor. Resistance is R2 and this is the diode and there you have a resistor. Okay, and this is R1. And in the negative cycle, let's say if in the positive cycle the potential at this point is positive, so in the negative cycle the potential at this point is negative and the potential at this point is positive. So during this cycle, source tries to move or push a current from this end to this end. Let's say the current is traveling through this branch. Okay, the current is coming. The current cannot go in this way. Why? This diode is reverse biased. So the current will travel in this part, this path. Let's say the current is I1, I1. The current will come to this point. The current cannot pass through this diode. Why? That is reverse biased. So it will go to this one, I1, and it will go to this one, I1, and the current comes to the negative terminal. So during the positive cycle, the current travels in this part, this path. So the current is traveling through two diodes and through two resistors, right? No current through these two diodes. Now in the negative cycle, the current is coming in this way, right? Let's say the current is I2. Current is coming in this way. So this is reverse bias. So no current through these two diode and the resistor. So same I2 is going in this way. I2 is going in this way. No current to this one. So I2 is going in this way. So I2 completes the circuit, right? Here, at this part, here I1, I1, I1. So I1 travels to this one and this one, this one and this one. Here, I2 is traveling to these two diodes and only to this resistor. So what can you say about the currents I1 and I2? Which one is the greater one? I1 and I2. Here, the potential difference is 0.7. Here the drop is 0.7. Okay. So how to find the current to these two I1? I1 is, let's say the supply voltage is E minus 1.4 divided by R1 plus R2, right? Here, what is the current? E minus 1.7 is 1.4. So E minus 1.4, right? Over R1 is the current. Here R1 plus R2. So what is the greater current? I2 is greater, right? In this case, current is flowing through two diodes and two resistors. Here, the current is flowing through only two diodes and one resistor. Clear? So the current at this point is large. Alright. Then method බලන්න. Then now let's go to the answers. 30. The direction of the current flowing through R2 changes from moment to moment. Wrong, right? Here, the first case, this is 13th one, statement A. At the first case, current to R2 is in direction. At the second case, current to R2 is 0. So current doesn't change direction. That is wrong. B, current flowing through R1 always flows through R2. Wrong. At this case, the current flows through R1 flows through R1. That is correct. But for that case, the current flowing through R1 is not flowing through R2. So that is wrong. C statement. At some point, current flowing through R1 is greater than the current flowing through R2. That is correct. Why that is correct? At some point, the current flowing through R1 is greater than the current flowing through R2. Here, see, at this point, the current flowing through R1 is not 0, but here the current is 0. So at this case, the current flowing through R1 is greater than this one. So that is correct. So answer is C correct. Answer is third one. For the 13th one, answer is 3. Sorry. For the 13th one, answer is 3. Sorry. Putala, in the question, they are asking the incorrect statements. What are the incorrect statements? C is correct. B and C are incorrect. So the answer is fourth one. They are asking not the correct one, but the incorrect one. A and B are incorrect. The direction of the current flow into R2 changes from moment to moment is wrong. Current flow into R1 always flows to R2 is also wrong. At some point, current to R1 is greater than R2. That is correct. At this case, the current flow into R1 is greater than this one. Here no current. Here there is a current. So that is greater than this one. That is correct. Wrong answers are A and B. So the answer is fourth. Right. Hari, put on next question. 14. Okay, 14th question. As shown in the figure, light is incident normal on one face of a prism. A liquid of refractive index mu is placed on the horizontal surface, horizontal face AC. The refractive index of the prism is 3/2. If the total internal reflection taken place on the face AC, okay, mu should be less than I root 3 of 4, where I is an integer. The value of I is. Now, Buddha, here the total internal reflection has taken place. That means the angle of incident at this place, that is the angle made with normal, right? This angle should be greater than the critical angle, right? That's why total internal reflection is happening at that place, that face, so that surface AC. Now mu should be lesser than this one. They are asking the value of I. Now, Putta, the refractive index of the medium is prism medium is 3/2, and the liquid is mu. First, since the total internal reflection is happening, we can say that the glass is rarer than the liquid. Okay, that means, Putala, first, this is 14th one. Now, first I'm going to find the critical angle. Let me find critical angle. Critical angle means this is the glass material. The refractive index is 3/2. And this is the liquid. The refractive index is mu. Critical angle means when the light incident, so this medium should be rarer. This medium should be denser. Then only we have a critical angle, okay? Then only the light is going to bend away from the normal when traveling from rarer to denser. Critical angle means when it is incident, when it hits the surface with critical angle, it will travel through the interface, right? So the angle of refraction is 90. You can apply Snell's law. Snell's law, V/2 sine C should be equal to, this one is mu sine 90, right? So you have 3/2 sine C equals to mu. Sine 90 is 1. Now, Putta, in the question, this is what's happening. Where you have 60-degree angle, 30-degree angle. See, Putta? See the diagram? This is 90. This is 60. There you have 30. Light is coming perpendicular. Have you got? Okay. Now the light is traveling perpendicular. Here the angle of incidence is 0. So the angle of refraction is 0. So the light is traveling undeviated. At this place, this is 90. Since this is 60, this is 30. So this is 60. They have mentioned that the light undergoes total internal reflection. Light undergoes total internal reflection means the angle of incidence, that is 60, should be greater than, okay, should be greater than the critical angle, right? Should be greater than C. Why? Then only the total internal reflection happen. If the angle of incident is greater than the critical angle, the total internal reflection will happen. So you can write 60 is greater than C. So sine 60 should be greater than sine C. Sine 60 is root 3/2 is greater than sine C. Sine C is how much? From this one, sine C is 2 mu over 3. 2 mu over 3, right? From this one, 2 mu over 3, right? Now, mu can be subjected, right? So how to write mu? Mu is 3 root 3. Sorry, mu should be lesser than 3 root 3 of 4. 3 root 3 of 4, right? Now, Buddha, in the question, If the total internal reflection takes taken place on the face, mu should be less than this one. So they are given that mu should be lesser than I root 3 or 4. I root 3 or 4. Appeng ahana, what is the value for I? Now we have found that mu should be lesser than 3 root 3 or 4. They have mentioned that mu should be lesser than I root 3 or 4. By comparing these two, you have I is equals to 3, right? I is equals to 3. We need to find the value of I. I is 3. So answer is something. What is the answer? I is 3, answer is third. Right? Answer is third. I is 3. For total internal reflection to happen, there are two conditions. There are two conditions. First one is the light should travel from rarer medium to a denser medium, and the angle of incidence should be greater than the critical angle. If these two conditions are satisfied, the light ray will undergo total internal reflection. Okay, next one. 15th one. 15th question. A Y-shaped resistor combination is shown in the figure or in the circuit. And the electric potentials at A, B and C are V1, V2 and V3 respectively. The potential at the point O is. Okay, Buddha, this is the circuit, a Y-shaped section. This is A. There you have a resistor. There is another resistor. And there is another resistor. This is point A, this is point B, and this point is point, let's say C. And the potential at this point is V1, V2, and the potential at this point is V3. Okay. Center point is so resistance is R1, there are R2, and there are R3. Okay. We need to find the potential at point O. How to do that one? The answers are in terms of V1. Okay. Hariputta, let's mark currents. Let's say current is traveling from there to there. So the current is I1. From there to there, current is I2. You can select either direction, okay? From there to there, so the current is I3. So current to this branch is I1. How to write current? Current is, let's say the potential at this point is V0. We need to find V0. So how to find the current? Current is potential difference or resistance, right? So you can write V1 minus V0 is equals to I1 times R1. Clear? I1 times R1. So for this branch, potential difference is V2 minus V0. That is, current is I2 times R2. For this branch, potential difference is V3 minus V0. That is, I3. The resistance is R3. From Kirchhoff's first law, you know the currents coming to a particular node is equal to current flowing away, right? All the currents are coming into this point and no current is going away. So you can write I1 plus I2 plus I3 is 0. Current coming into is equals to current going away. no current is flowing away. So you can write, now you can write I1. So Putala, how to write I1 from this one? V1 minus V naught over I2, V2 minus V naught over R2. I3, V3 minus V naught over R3. That should be equals to 0. Now Putala, you can break this into two parts, right? That is V1 over R1 minus V naught over R1. Same thing can be done to all these three terms, and you can take the negative terms to this side, and you can take V naught out. Then you have 1 over R1 plus 1 over R2 plus 1 over R3 is equal to V1 over R1 plus V2 over R2 plus V3 over R3, right? When you divide this one by this one, you have V naught. So V naught can be found. Very easy. So what is the answer? Let's move to the question. V1 R1 divide by this term, right? Divide by this term, that means this term to the power minus 1. So the answer is second one. Second one is the answer. When you divide this whole term by this term, that is this term to the power minus 1. So the answer is second one. For the 15th one, answer is second one. Write down. හරිනේ පුතා. අපි පොඩි බ්‍රේක් එකක් අරන් යමු. 20 minutes වගේ බ්‍රේක් එකක් අරගෙන මේ සෙට් වෙමු. හරිනේ? මේවා තේරුණාද? සෑම් තේරුණාද? වීහුල රොෂෙන් මෙතනකම් කරපු ටික ක්ලියර්ද? Yes sir. Yes. Sahan?
Oh, sir.
Sam?
Yes, sir.
Okay. We'll take a small break. Haributala. We'll start. Katinada.
Yes, sir.
Roshan, Sam, Pinula. Yes, Roshan is there.
Yes, sir.
Pinula. Sam is there. Pinula. Pinula. Yes, Pinula also there. Okay, we'll start. Question number 16, right? All right. Let me share the screen. Okay. This is the question. O is the center of mass of a circular plate of diameter 56. There is a larger circle of diameter 56. That means the radius 28. And C1 is the center of mass of the circular plate of diameter 42. That means the radius, how much? 42 means 21 centimeters. Which is removed from the first plate as shown in the figure. If C2 is the center of mass of the remaining portion, the length OC2 is. Okay. We'll do the question. Hi, Budala. 16th. There is a larger circle. Let's take this is x-axis, y-axis. This is the larger circle. Diameter is 56. So the radius or the center of gravity of this part, this one is C1, right? Sorry, O. O is the center of gravity of this one. So from here to here, the distance is how much? Diameter is 56. So the radius is 28 centimeter from here to here. Now, this distance also 28, right? Now, a circular disc of radius 42 centimeter is been removed. 42 means from here to here, diameter is 42. This section is removed from this one. Okay. The center of gravity of this one is somewhere there. That is, what is that one? That is C1. I can't remember. Yes, that is C1. This is C1. From here to here, let's say the distance is how much? Here, the distance diameter is 42. So from here to here, this is 21 centimeters, right? So now the remaining part is this section. This is the remaining section. If the total circle was there, the center of gravity is at this point. The center of gravity of this removed or the removed section is C1, right? Now from this circle, this section is removed, and now the center of gravity of this section is somewhere there. That location is C2. This location is C1, and this is C2. We need to find the distance OC2, right? OC2. That is the question. See, we need to find OC2 distance. So we need to find the location. If you know the location of C2, you can find OC2. Very easy. කොහොමද කරන්නේ පුතාලා මේක? Now, let's say the mass of the circle is proportional to the area, right? Why? This is a uniform disk. Area times density is the mass. So the mass of this larger disk, let's say M1, is equal. We can assume that is equal to area. That is pi r square. Radius of the larger circle is 28. So 28 square. The mass of the larger circle is pi 28 square. The mass of the removed section is M2. That is pi times radius of this one is 21 square. So the remaining mass is the difference. Okay. Now I'm going to take moments about y-axis. So I'm going to take moments about y-axis. if you combine this part to this part, you will get the entire circle. So the entire circle center of gravity is somewhere there. So, yes. So when you take the moment about y, the moment of the larger disk about y is equal to the addition of the moments from this section and from this section, right? So when you take moment about y-axis, if the total disk was there, the mass is 5 times 28 square. The center of gravity will be 28 centimeter from this end. So mass times 28 should be equal to the addition of this section plus this section. So the mass of this section is what? The total mass is pi times 28 square. And you are going to remove this section. So the mass of this shaded region is the difference. That is, you can take pi out. 28 square minus 21 square. That is the mass. The distance to its center of gravity is from here to here, let's say x bar. From here to here, the distance is x bar. From here to here, that is the distance, the center of gravity of this section. So that is x bar plus the center of gravity of this part. The moment from this part. The mass of this one is pi times 21 square. The distance to the center of gravity, what is this distance? The total distance from here to here is 56. From here to here, 21. So from here to here, the distance is how much? 535. Clear? 35 centimeters times 35. තේරුණනේ පුතාලා? එහෙමයි ගන්න. Now, ආයක පාරක් කියන්න. නේද? You are going to take moment about pi. If the total disk is there, the center of gravity is here. So when you take the moment, the total mass is this one, pi times 28 square. From here to here distance, from here to here the distance is 28. So mass times distance should be equal to the addition of the moment of this section plus this section. The mass of this section is the difference of these two. The center of gravity is somewhere there. And the mass of this section is this one. The center of gravity from here to here, the distance is 35. Now only the unknown term is x bar. You can find x bar. You can cancel pi. Then you can take those things. Here 28 square minus 21 square is difference of two squares. That is the addition plus the difference. Addition is how much? 28 plus 21 is 49. 49 into 7. X bar is equals to here 28 cube minus 21 square times 35. Now you can divide this one by 7. Or somehow you can find 28 cube minus 21 square into 35 divided by, there you have 7 to the power 3 if you need. 7 to the power 3. From this one you can find x bar. You can easily simplify this one, okay? How to simplify this one? This is 28 over 7 cube minus 21 into 21 into 35 divided by 7 into 7 into 7, right? Here you have 28 over 7 is 4. 4 to the power 3, right? There you have 3. There you have 3. There you have 5. From this one, 3 into 3, 9. 9 into 5 is how much? 9 into 5 is 45. 60, there are 64 minus 45. That is 90. X bar is 19 centimeters. Clear? 55, yes, 19 centimeter. Now you know this distance. Then how to find this distance? We need to find OC2 distance. This distance. So OC2 distance is 28 centimeters minus 9 centimeters. That is how much? 9 centimeters. So distance is 9 centimeters. So the answer is 9 centimeters. Answer is 35. We find OC2 distance, that is 9 centimeters. Answer is third one. Third one is the answer. Right on. හරිද පුතාලා? Okay, next question, 17th one. 17th question. A body of mass 5 kilogram moves along the x-axis with a velocity 2 meters per second. A body of mass 5 moving with a velocity 2 along the x-axis. This is 70. This direction. Right. Hurry. Body of mass 5 kilogram moves along the x-axis with a velocity of 2 meters per second. So the linear momentum is 10, right? 10 kg ms minus 1. Mass is 5 kilogram. Velocity is 2 meters per second. So the linear momentum is 10. A second body of mass 10 kilogram moves along the y-axis with a velocity of root 3. There you have a 10 kilogram mass moving with a velocity v2, that is root 3 meters per second. They collide at the origin and stick together. If v is the velocity of the combined mass after the collision, theta is the acute angle made by v with x-axis, and E is the heat liberated in the collision. Okay, the correct statement. Okay. Now, Butala, see the board. 5 kilogram is moving in this direction with a velocity 2. So the linear momentum is 10. 10 kilogram is moving in this direction with a velocity root 3. So the linear momentum P2 is 10 root 3 meters per second. So after the collision, they stick together. So the total mass is 15 kilogram. We don't know the linear momentum in this direction and linear momentum in this direction. So it is moving with a velocity v. The angle is theta. So Putala, after the collision, according to the conservation of linear momentum, after the total initial linear, this is very easy. The total initial linear momentum should be equal to the final linear momentum. So initial horizontal linear momentum is 10. So after the collision, the final horizontal linear momentum should also be 10. Initial vertical linear momentum is 10 root 3. So after the collision, the final linear momentum should also be 10 root 3 kg ms minus 1. Right? Kg ms minus 1. Right? Now, Putta, we can find the final linear momentum. How to find the final linear momentum? The resultant of these two is the final linear momentum, right? So how to find the final linear momentum? 10 square plus 10 root 3 square, the square root. You can 10 out. inside root you have 4, that is 20 kg ms minus 1 is the final linear momentum, right? You know the final linear momentum, that is mass into velocity, final velocity. So you can find the velocity. So 20 equals to final mass is 15 times velocity. So velocity is 4 over 3 meters per second. This is the final velocity of the object. And you can also find the angle. How to find angle, Putala? Tan theta is opposite over adjacent, right? Opposite is 10 root 3. Adjacent is 10. So that is root 3. So theta is 60 degrees. So angle made with the x direction is 60 degrees. Then again we need to find the energy liberated. So we need to find the difference in the energies, right? So Lama, if two objects collide and stick together after the collision is a perfectly inelastic collision. The energy loss is maximum, right? So we need to find the loss in energy, delta E. So initial energy is greater, the energy of that one half into 5 into 2 square, right? Minus energy of this one half into mass 10, velocity root 3 square, minus final energy is half into mass 15, velocity is 4 over 3 square of that one, square of that one. Okay. Now you can delta E is, then you have 5 into 2 10 minus 5 into 3 15, sorry, plus 15 minus uh, half into 15 into 4 into 4 over 9. Okay, 2 times 2, 3, 5. Then this is 25 minus 40 over 3. That is 75 minus 40 over 3. That is 35 over 3 joules. This is the loss in energy. Angle is 60. Loss is 35 over 3. Final velocity is 4 over 3, right? Now, Buddha, here what I did was, here, this is a collision. So for a collision, you can apply conservation of linear momentum. So initial horizontal linear momentum should be equal to the final, right? So initial horizontal is 10, so final should also be 10. Initial vertical is 10 root 3, so final also 10 root 3. From this one, by taking the resultant, you can find the resultant linear momentum. As you know, the resultant linear momentum, that is mass into velocity, you can find the velocity, and as angle can be formed, energy can be formed. So answers are, so the answer is, velocity is what? 4 over 3. So 4 over 3, angle is 60. Energy is, Putala, 35 over 3. So this is the answer, right? 4 over 3, 60 degrees, 35 over 3. Answer is fourth one. Fourth one is the answer for the 17th one. For the 17th one, answer is 4. Write down. Okay. හරි පුතා 18. There is a smooth inclined plane in an elevator. An object is released from rest on the top of this inclined plane. When the elevator is at rest, it takes time t1 to reach the bottom. It takes time t2 when the same motion, for the same motion when the elevator is moving up with an acceleration, then the ratio of t1 over t2. Yeah, okay. 18th question. Now there is an inclined plane, right? First, this is 18. First, the elevator was at rest. This is for the rest. It is going to travel from there to there. Starts from rest, travel to this point. Starting from rest, travel to this point. Let's say the distance is x. Initially, the lift was at rest. When it is traveling, what are the forces? You have r. In this direction, you have mg sine theta, and you have mg cos theta. Friction smooth, that is given. The surface is smooth. So Putala, you can find the acceleration in this direction, right? When you apply F equal ma, the acceleration is g sine theta. So Puta, to find time taken, you can apply s equals to ut plus half a t square in this direction. The distance is x, initial velocity 0, acceleration is what? G sine theta. They have mentioned that the time taken is t1. So t1 square. So t1 is what? 2x over g sine theta, the square root. This is the time taken to travel from there to there. Now the lift is accelerating, Putala. Upward with an acceleration. The same motion repeats, starting from rest, travel to this point. The same distance x is there. What are the forces? Now you have normal reaction. At this place, you have m g plus a cos theta, right? There you have m g plus a sine theta. Why? When this is traveling upward, rather than mg, you have another force in the downward direction, that is ma, pseudo force. So the components of mg plus ma is mg plus a sine theta, mg plus a cos theta. So the acceleration in this direction is what? G plus a sine theta. Clear? G plus a sine theta. By considering this motion, similarly, you can write the time taken is by looking at this equation, that is 2x divided by g plus a sine theta, right? You can apply c equals ut in this direction. The same thing will happen. The only difference is here you have g plus a sine theta, because the acceleration is g plus a sine theta. There the acceleration is g sine theta. Now we need to find the ratio in between t1 and t2. How to find the ratio, Putala? T1 over t2. When you divide these two, the square root of this one. 2x will be gone. This divided by this one, that is g plus a sine theta divided by g sine theta, the square root. Sine theta will be gone, that is 1 plus a over g, the square root. 1 plus a over g, the square root. So the answer is 1 plus a over g sine root. Answer is fifth one. See, this is the answer. Fifth one is the answer. Right?
සර් ඇයි එතන ප්ලස් A වෙන්නේ?
එතන පුතා මෙහෙමනේ වෙන්නේ. ඒක දන්නේ නැද්ද? when මේක lift එක නම්. එහෙමනේ. Forces mark කරොත් when this is traveling with an acceleration a, what are the forces? You have normal reaction, you have weight. With respect to the lift, there is another force in the downward direction, that is ma is there. When it is traveling upward, ma force will be in vertically downward. if it is traveling downward, MA should be opposite to this one. මතකද මෙහෙම එකක් කියලා දුන්නා. ඔය past paper එක තිබ්බා. There is a lorry. This is a lorry. When this one is traveling with an acceleration A, there will be a force in this direction. That is, if the mass of this box is m, the force is m times a. If it is traveling this direction, there will be a force in the opposite direction that is known as pseudo force. Pseudo force will be in the opposite direction ma. Similarly, when this is traveling with an acceleration a upward, there will be opposing force or pseudo force in the downward direction ma. තේරුණාද? එතකොට මෙයාගේ components ගත්තොත් මෙහෙට එනවා mg plus ma sin theta, there mg plus ma cos theta. Clear? සහන්
Okay, හරි sir.
මෙහෙමයි. right off. Let me erase. හරි පුතාලා, next one. 90. The balance length of the potentiometer given below is L when the switch S is, where is the switch? S is open. It is not marked, but we can assume this is the switch S, right? This is switch S. This is, there are no any other switches. So this should be the switch. S is open. So when S is open, the balance length is L. And the balance length decreased by L over 3. When the balance length decreased by L over 3 means the new balance length is 2L over 3. L minus L over 3. When it is closed, what is the internal resistance R of the cell E? I'll draw this on 90. This is from electricity. This is the cell E node, primary circuit, and there you have a secondary circuit. In the secondary circuit, what do you have, Puta? You have a cell E and a resistor R and switch. Switch is there, right? Then there is a galvanometer. Okay. Having E and the internal resistance is R, and this one is capital R. Hari Putala. Now, when the switch S is open, that means at this point, the balance length is L, right? This balance length is L. So at the balance length, you can write there will be no any no current coming in, no current flowing to this galvanometer, right? So the potential difference across this one and this one are the same. So you can write E is equals to K times L, right? K is the potential gradient, L is the balance length. K is the potential gradient. You know these things, potential gradient. Now you are going to close this switch. Now you are going to close this switch. When you close this switch, the balance length decreased by L over 3. So the new balance length is what? New balance length is 2L/3, right? When you close this switch. Now, no, the current through this branch is 0, the current through this branch is 0. But since this circuit is activated, there will be a current through this circuit, right? Let's say there will be a current I through this circuit. Now you can write what is the potential difference across this one? From the potential divider theorem, the supplied voltage is E. E is divided among capital R and the internal resistance. So how to find the potential difference? Potential difference is total voltage times capital R divided by the addition, right? From the potential divider theorem. So this is the potential difference across this one, that is equals to this one, that is equals to this one, right? So the potential difference is E times R divided by R plus R. That should be equal to the potential difference across this one. That is K times L. Now the balance length is 2L/3. 2L/3. Now we need to find the internal resistance, simple R. Now you can divide these two. This is first one, this is second one. You can divide 1 by 2. When you divide, E will be gone, K is gone, L is gone. So you have the reciprocal of this one, right? R plus R over R is equals to 3/2. Now you have 2 capital R, 2 simple R equals to 3 capital R. So 2 simple R equals to capital R. So simple R is R over 2. So internal resistance of the cell is capital R over 2. So the answer is what? What is the answer? Answer is Puta R over 2. Second one is the answer. Write down. Second one is the answer. Second one is the answer. Right, Putala? Okay, next one, 20. The breakdown voltage of a Zener. Now you have a Zener voltage is 5 volt. So always the Zener diode should be reverse biased. The breakdown voltage is 5 volt. That means the maximum reverse voltage across the Zener is 5 volt. The internal resistance of the cell is negligible. Okay. And the resistance capital R. Yeah, there you have a capital. Here, see. This resistance, there is a variable resistor. R can be varied in the range 0 to 25. The maximum for this one is 25 and the minimum is 0. Consider following. The maximum value for I is this current, right? The maximum current is this one much. The minimum value is this much. The maximum current to the Zener diode is 0.1 ampere. Let's see. First, I need to draw this diagram. 20. There is another resistor. There you go. There is a variable resistor, and there is another resistor, load resistor, and the Zener is there. See, Zener is reverse biased. The voltage here is 10 volt, and the resistance here is 100 ohms, and the resistance here is 25 volts, 25 ohms. The variable resistor is there. The current is I. Zener voltage is 5 volt given. This is 50 ohms. That is also given. The resistance can be varied from 0 to 25. Let's move to the question. Now we need to find the maximum and the minimum current and the maximum current to the Zener diode. Now this resistance can be varied from 0 to 25. First, I'll assume when the resistance is 0. This one is 0. That means there is no any resistor. So Buddha, when this is 0. Now Buddha, when this is 0, let's assume, see, this is, if this resistance is 50, if this resistance is 50, this is 50 and this is 50. Let's say there is no any current to this one. So the potential difference across this one should be 5 volt. Right? If this is 50, if this is 50 and this is 50, this will be divided equally. That means here 5, here 5. But here the resistance is 25. They are 50. Now the potential difference across this one, if this is 25 and if this is 50 ohm and this is 50 ohm. Now the supplied voltage is 10. Then the potential difference across this one is 5, right? But here this is 25 ohms. So now the potential difference across this one should be greater than 5 volt. It cannot happen. Why? There is a Zener diode connected. The potential difference across the Zener diode cannot be greater than 5 volt. Now the Zener diode is at 5 volt. That means the potential difference across this one is 5 volt. Right? So this is 5. The total supply voltage is 10. So the potential difference across this one is 5 volt. So what is the current through this branch, Putala? Again, what is the current through this branch? Current is potential difference V over 25. That is 5 over 25. 5 over 25 is, Putala, 1 over 5. That is 0.2 amperes. So the current through this branch is 0.2 ampere. So current through this branch, what is the current through this branch? Potential difference is 5. 5 over 50 is 0.1. So the current through this branch is 0.1 amperes. So the remaining current is passing through this one. So the current through the Zener is 0.1 ampere. 0.2 is coming. There will be a current 0.1 passing through this, the resistor. So the remaining 0.1 is traveling to this resistor. So also this. Now, Buddha, next instance is the resistance across this one can be varied from 0 to 25. Now let's take when R equals to 25 ohms. So Butala, I'll draw only this branch. You have a resistor, you have another resistor, you have another resistor, you have a Zener diode. There you have the Zener diode, and the supplied voltage is 10 volt. Now here 25 ohms. Now the resistance is not 0 but 25. There you have a 50 ohms. Now Butala, there are 25. There are the resistance is 50. Now what happens is this 10 will equally divide among these two, right? So the potential difference across these two is how much? 5 volt. The potential difference across this one is 5 volt. That means at this instance, the Zener is at the verge of breaking down. Breakdown වෙන්න ඔන්න මෙන්න අවස්ථාවේදී ඉන්නේ. හරිද? මෙතනදී Zener එක breakdown Zener has already broken down. හරිද? මේ ඒ කියන්නේ breakdown වෙලා ඉන්නේ මෙතනදී. මෙතනදී the Zener is at the verge of breaking down. So the potential difference across this one is 5 volt. The potential difference across this 2 is 5 volt. So the current is how much? 5 over 50, that is 0.1 ampere. Here, the current is 0.1 ampere. So the current through this branch is 0. Current through this branch is 0. See, at this point, that means when the resistance is 25, here, when the resistance is 25, the current through this branch is 0.1. And the current through this branch is 0.1. So there will be no any current through this branch. Right? When this is 0, that means there is no any resistance. When this is 0, current through this branch is 0.2. So a 0.1 current will travel to this branch. So another 0.1, the remaining 0.1 has to be traveling in this branch, right? Every other instance, that means the resistance is in between 25 ohms and 0 ohms, right? When this is 25, no current. When this is 0, current is 0.1. So every other instant, the resistance is in between those two. So the current to this branch is always 0.1. Why? What is the reason? The current to this branch, the voltage is 5, resistance is 50. So the current to this branch is always 0.1 ampere. So every other instant, the current to this branch is in between 0.1 ampere and 0 ampere. See? So the current to this branch cannot be greater than 0.1. The minimum is 0. The current to this branch is always 0.1 ampere. We use a Zener diode to regulate the current through a resistor or regulate the potential difference across the resistor. So the down voltage is 5 volt. The voltage across the Zener is 5 volt. Sorry, the voltage across this resistor is 5 volt. Resistance is 50. So always the current is 0.1 ampere. So when you vary this resistance from 0 to 25, what happens is the current through this branch will gradually decrease until it is equal to 0.1 ampere. The maximum current is 0.2 amperes. The minimum current is 0.1 ampere. When the current through this branch is fluctuating, the current through this resistor will always remain the same. But the current through this branch will keep on decreasing. Here 0.1 ampere. When you increase the resistance, this 0.1 ampere will decrease, and finally it will become 0. Clear? Very important. So the maximum current through this branch is 0.2, minimum is 0.1. Clear? Maximum is 0.2, minimum is 0.1. Current to this one is always constant 0.1. The maximum current to this one is 0.1. The minimum is 0. So those are the conditions. Now let's move to the question. See, Buddha. The maximum value for I is 0.13. That is wrong. Not 0.13, 0.2. The minimum value for I is 0.1. Yes, that is correct. The minimum value current to the is 0.1. That is correct. B is correct. The maximum current to the Zener diode is 0.1. That is also correct. So B and C are correct. Answer is third one. First one is wrong. Answer is third one. Write down. Third one is the answer for the 20th one. For the 20th one, answer is 3. Write down Putala. Hurry. Next one. 21st one. 21st one. The rate of steady volume flow of water through a capillary tube of length L and radius R under pressure difference P is V. The volume flow rate is V. Now here pressure difference. So you, by reading the question, you can assume that this is from Poisson, right? So from Poisson, Q dot T equals to pi R to the power 4 over 8 theta delta P over delta L. The volume flow rate is V equals to pi R to the power 4 8 theta. Pressure difference is P, length is L. That is given. What is the rate of steady flow through a series of combination of these tubes with another tube of same length and half the radius if the same pressure difference P is maintained across the combination? Now we need to find the volume flow rate. Same length but twice the radius. Hari puta. Now from Poisson, Q dot T equals to pi R to the power 4, this one. Radius is R, pressure difference is P, length is L. Now two tubes are connected in series. Radius is R, yes. Same length. Two tubes are connected in series. Same length, LL. The radius is R over 2. So when tubes are connected, now let's say the volume flow rate is V dash. Since they are connected in series, the same flow has to be traveled through this tube. So if the flow rate to this one is V dash, the flow rate to this one should also be V dash. Let's apply Poisson to the first tube. So V dash is equal to pi R to the power 4 8 theta. Let's say the pressure difference is delta P1. Pressure difference is delta P1. Pi R to the power 4 8 theta, delta PO length is L for the first tube. Now you can subject pressure difference across the first tube. That is equal to what? When you subject V dash 8 eta L divided by pi R to the power 4. Now consider the second tube, this one. When you take the second tube, the volume flow rate is same. So V dash is equals to pi. Now the radius is R over 2. So R over 2 to the power 4. So 2 to the power 4 is how much? 2 into 2, 4, 8, 16, right? So that is R to the power 4 times 16 8 theta. Let's say pressure difference of the second tube is delta P2. So the pressure difference is delta P2. Length is L minus. Same length, L. So now you can subject delta P2. Delta P2 is what, Puta? Delta P2 is V dash 2 into 2, 4, 4 into 2, 8, 8 into 2, 16, right? I'm correct, right? Yes. Pi R to the power 4, 8 theta. Same length, right? Yes. Now, when you subject V dash, you have multiply this one, 16 V dash times 8 eta L divided by pi R to the power 4. This is the pressure difference across the same tube. But they have given that the total pressure difference is also same as the previous tube. The total pressure difference is P. So that should be equal to the pressure difference across this tube plus the pressure difference across this tube. So P equals to delta P1 plus delta P2. Am I clear? So delta P1 is this one. You can, this one plus this one. You can take V dash 8 theta L pi R to the power 4 out. So you have 1 plus 16, that is 17, right? When you add these two, you can take, so you have 17 times V dash 8 theta L over pi R to the power 4, that is P. Now, Puta, you can subject V dash. So V dash is what? Pi R to the power 4. Okay? Divide by 17, 8 eta L times P. So that is V dash equals to 1 over 17 times pi R to the power 4 P 8 eta L. Right? So this is equal to this one. See, this is V, right? So V dash equals to what? Here, V dash equals to, this is V. So V over 70. So the new, with the same, with the same pressure difference, the new flow rate is 1 over 17 times the initial flow rate, right? This is the initial flow rate when only this tube was present. Now there are two tubes, but the same pressure difference is maintained. So the flow rate has decreased by 17 times. So the answer is VO 17. I don't know what is the answer. Answer number is VO 17. Second one is the answer. Second one is the answer. Write down Putala. Hari Putala. This is enough for the day. We'll do another class on this Saturday, and we have the usual class on next Wednesday. And also, I'll do another class on the coming Saturday as well. Okay. So every week you have two classes, Wednesday and Saturday. Okay. Is it all right? San, Winler? Winler, for you, I can give you a recording. I'll try to give you a recording, a YouTube video or something. Sahan, Roshan, and Sam, you're all right. Right? Are you okay with that one?
Okay, sir.
හරි පුතාලා එහෙනම්. Set. Wait Winler. මේ Saturday night නම් Winler මට මේ වෙන class එකක් දෙනවා පුතා. මම record එකක් දෙන්න බලන්න. I'll try. හරිලා එහෙනම් මේ God bless you. අපි next this Saturday meet වෙමු. හරිද? එහෙනම් God bless you ළමයි. Good night.
Good night, sir.